For the rest of this chapter, we're going to be looking at types of chemical reactions, basic types of chemical reactions that are really important in chemistry. And we're going to start with one of the most important types of chemical reactions and chemicals that exist in chemistry, which are acids and bases. Acids and bases show up everywhere. They're in our bodies. In fact, you've probably heard of the amino acids. Those are, as the name implies, acids. You're probably familiar with DNA, which is deoxyribonucleic acid. So nucleic acids. So a lot of biochemistry revolves around acid-base chemistry, and not just biochemistry. Lots of things outside of biochemistry rely on the interaction between acids and bases. So what are acids and bases? Let's start there. What defines something? And so there are a few different ways of defining acids and bases, but we're going to stick with what's known as the Bronsted-Lowry in this class. This is spelled like this, Bronsted-Lowry definitions of acids and bases. There are a few other ones that we could use, but this is a good starting place. So the Bronsted-Lowry definition of an acid is that it is a proton donor, and for a base is a chemical that is a proton acceptor. And generally, we're talking about in aqueous solution here, as I've said earlier for this chapter. So what does this mean? Let's look at a couple examples of acids and bases, and I think that will clarify what we mean here. So there are many acids. So one really common acid is HCl, hydrochloric acid. This is a compound you should be able to name. And when we put hydrochloric acid in water as a solvent, so HCl is our solute, water is our solvent, the HCl breaks up into two parts. It's basically acts as an ionic compound. And so when the HCl enters the solvent, we get a combination of H plus ions and Cl minus or chloride ions. Now when we say something's a proton donor, what we're talking about is this right here. An H plus ion, if we think about the periodic table, hydrogen only has one electron and one proton. When it loses that one electron, it becomes just a bare proton. And so that's what we're talking about when we talk about a proton donor. It's this H plus. Now I will just mention that this is a simplified, we sometimes write H plus, but a more accurate way of looking at this is the proton will actually attach onto a water molecule. These two will combine, and these will form what's known as a hydronium ion. And we write that as H3O plus, and that's just the fact that the proton doesn't just exist by itself in water. It will attach onto that positive charge will attach onto a water molecule. And even this is a little bit of a simplified picture of what actually happens with protons in water. But you can write it anyway. You can write it as H plus, you can write it as H3O plus. Both of those mean the same thing, just a proton that's dissolved in water. And so HCl is a very good proton donor. It's a very good acid because it donates those protons. And so if we sort of write what happens when we put this in water as a chemical equation, rather than just sort of drawing it here, we would have HCl plus water, and we would get our hydronium ion, H3O plus our chloride ion. So when we add that HCl into water, it completely dissolves and forms these two ions. So that's an example of a proton donor. HCl is a very common one, but there's lots of other ones. And it's essentially anything that produces these H plus ions in water is an acid. Produces these, it's an acid. Now, bases, on the other hand, are things that accept protons. Actually, in this example reaction that I've drawn here, H2O is acting as a base because it is accepting the proton from our hydrochloric acid to form H3O plus. That's one example of a proton acceptor. Let's look at some other common ones. Again, we'll look at a specific molecule, sodium hydroxide here, NaOH. And many bases, not all, but many bases involve this OH minus ion. Sodium hydroxide is an ionic compound. When we add it to water, it separates into sodium ions and hydroxide ions. And it's actually this part, the hydroxide, that is the base. Because if you combine hydroxide with protons, it accepts those protons and forms water. And so there are multiple different ways of having proton acceptors, but one of the most common is to have a metal ion plus hydroxide ions, because those hydroxide ions act as a proton acceptor and are bases. So we'll stop there. This is an introduction to acids and bases. That acids are proton donors. They produce H+ ions in solution. Bases are chemicals that accept those protons in a chemical reaction, often to form water, but not just water. There are other ways that you can, for example, like H2O here acting as a proton acceptor, is acting as a base. And so that's our first introduction to acids and bases. In the next video, we're going to talk about different types of acids and bases and how we can classify them as either strong acids or weak acids, and strong bases and weak bases, and what that means.